Hello, my name is Amy, and this is an experiment regarding Archimedes' principle for physics lab. Archimedes' principle basically states that the buoyant force applied to an object is equal to the weight of the fluid the object displaces. An object moves a fluid so it can occupy the volume the fluid originally occupied. The buoyancy force is the force applied upward on an object by any fluid. So basically we have two cups here with the exact same amount of liquid, which is about 3/4 cup, and I'm going to add 20 milliliters of ice to this cup, and they're kind of cut smaller. So as you can see, the water level rose. Originally it's kind of like below the blue line a little, now it rose up to there. And I'm also going to add in this cup a block of ice, same amount, with a nail inside. There's the nail if you can see it, and it's kind of sinking because the nail is more toward the bottom of the ice cube. Okay, so the basic calculations that go into this experiment, and I'll put this over here so you can see as the ice melts, that we can predict that the one with the ice cube, the water level is going to stay the same, and the one with the nail in the ice, that the water level is actually going to go down. So we have this idea that the buoyant force is the weight of displaced water. So the buoyant force is equal to the mass of the water, and the gravitational force is equal to the density of water times the volume of the water displaced, also times gravitational force. So the mass of the water is the density of the water times the volume of the water displaced. So the weight of the ice cube is the mass of the ice times the gravitational force is equal to the density of the ice times the volume of the ice times the gravitational force. But since the ice cube is floating, the buoyant force is equal to the weight. Setting the equation here equal to each other and then rearranging it, you can solve for the volume of the water displaced by the ice cube, which is this. Okay, so this is the volume of the water that the ice cube displaced. So what is the volume of the water that the ice cube adds on once it melts? So since we know that the mass of the ice cube is the same as the mass of the water left after it melts, you can write this, that the density of the ice and the volume of the ice is equal to the density of the water and the volume of the water. So the total volume is basically just the density of the ice times the volume of the ice and the density of the water, which is exactly the same volume as before. So when the ice cube melts, it fills up exactly the same amount of volume as the water displaced to hold up the ice cube, because there's a force holding up the ice cube. So the water level, it remains the same. Okay, so now back to our experiment here. It's taking a while, but you can see here that the ice has pretty much all melted here. And we have an ice cube with the nail in it, which is going to take a little longer to melt. So the nail has basically fallen out of the ice, and we could see the water level is a little bit higher, but once that ice cube melts, it should get a little lower, because the density of the nail is greater than the density of the water, which is greater than density of ice, which is greater than the density of the air. And the volume of the ice that is submerged under the water before melting should equal the volume of the water formed after melting. It's the idea of displacement by Archimedes. The buoyant force on the ice cube is equal to the weight of the displaced water. So when it melts, the mass of the ice and the water are going to be the same. The displaced volume, again, after the ice melts, is going to be greater than the volume of the total water and ice. So the water goes down with the nail embedded. And that's because the nail was taking up space in the ice. And as we know, the mass of water is 1 gram per centimeter cubed. Our ice cube now has just about melted away. And there's our nail at the bottom. So, as you can see here, with the first cup, the level of water stayed the same after adding that 20 grams of ice in there. And over here, 20 grams with the nail